Starting. Very good afternoon, judges, ladies and gentlemen. We are Team Ingenious from Republic Polytechnic. I'm Jingyi. These are my teammates Qingyuan and Li Can. We are honored to be here to share our topic about robotic logistics and yes, related with pharmaceutical supply chain. Okay, we will go through the problems, the new hospital flow, the improved pharmacy flow, and opportunities of implementing robotics in pharmacy, the simulation models, and the improvements in the future. Before we starting our topic, we will show you a photo. Yes, as you can see, there are a lot of people waiting in the pharmacy. Nowadays, in Singapore, people will usually take half day or even 1 day spending in hospital. It will also take a long time for them to collect medicines in pharmacy. Yeah. To mitigate this situation, we may suggest a hospital to hire more staffs or train the staff to achieve a higher service level. However, these are not sustainable solutions, as in they may only have a limit improvements. Once the amount of patients increase, the service level will become low again. So we turn to look into the hospital internal supply chain and focus on the and look into the internal process and supply chain. We will focus on improve. Our target today is to improve the supply chain within pharmacy, and my teammate Li Can will introduce more about the supply chain in the hospital.
Okay, thank you. Firstly, I will introduce you guys the pharmaceutical flow in the hospital. Basically, there are 3 stages. The first is the inbound. When the medicines come to the loading bay of the hospital, which is the first stages, and all the medicines will be unloading and sorting according to their storage requirement, which will store to the storeroom, which is the second stage, and come to the last stage. All the medicines in cartons will be broken bags and stored to the pharmacy. And this is the third stage, and which is the most significant stage we're going to optimize. Okay, this slide I'm going to show you how the automation system going to improve the service level for the patients. For the current situation, the manual picking system, when the patient finishes the consulting with the doctor, he need go to the pharmacy to wait for his turn to hand in the prescription list. And apart from that, he also need wait for the pharmacist prepare his medicines ready, and which is a long process. And the patient going to wait for a very long time for the manual picking system. But once the hospital implement the automation system, when the patient finish consulting with doctor, the doctor will send the e-prescription to the pharmacy through the internal system. And by the time the patient reach the pharmacy, all the his medicines has been prepared ready and waiting for his collection. My teammate Qingyuan going to elaborate some more about the process.
Thank you. Now we are going to show you a video, and this video is about the manual process and the automation process.
Do you think the staff has wasted a lot of time in searching the medicines? We got a new plan. Medicines will be arranged in a particular order, and the picking robot will select the medicine based on the prescription. It takes less than 4 seconds to pick the medicines. It's also able to pick both strips and box. The prescription will be printed on the plastic bag, which contains the medicines. The medicine basket will travel along the conveyor belts. There are some light sensors to detect and control the movements of basket. Once the basket arrives at the dispensing area, the robotic arm will arrange it to one empty cubicle and update the picking point to medicine companion.
Now Lisan will explain more about the medicine companion.
Nowadays, the smartphone is more and more useful in our life. People cannot live without it. So we come out this app, so-called Medicine Companion, to improve the service level for the patients. The patient can download the Medicine Companion. When he finishes the consulting with the doctor will pass him the prescription list, which is a QR code on it. He can use this app, the scan function, to scan the QR code. It will show the information of the medicine status. If the medicine is still pending, they will show the estimate time. And once the patient is prepared ready, he will show the picking point of his medicine. And apart from that, this app also shows what are the medicines inside and how often to take it. And it's also available for the user to set an alarm to remind him to take the medicine on time.
And this video will explain how the patient collect their medicines.
This example will show you how the bump box works in the hospital. Once the patient receives the message from the medicine companion, they will go to bump box directly, and bump box is an automation self-collection locker. After scanning the QR code, bump box will open the corresponding cubicle. Then the patient can collect their medicine packages.
Okay, now I will pass to my teammate Jingyi.
So the implementation of robotic system in pharmacy can contribute to 3 main advantages. The first one is it can help to achieve help to create a better and more controllable environment for pharmaceuticals. Second one is there will be less access to prescription medicine, as in only a few authorized staff can access to the storeroom. The last one is it can help the hospital to keep all the medicines under check and have a better control of the stocks. Okay, lastly, it will help the hospital to keep all the medicines under check and have a better control of the stock. Once one kind of medicines is lower than certain value, it will remind the pharmacist to add more stocks. And on the other hand, it can, when the doctor's giving the prescription, it can have access to the stock condition. And if one medicine is out of stock, it can give the alternative medicine directly rather than the patients have to go back again. And Just now are the opportunities and benefits of implementing robotic system. You may wonder how well exactly the robotic can help to improve the simulation, help to improve on the whole process. So we create 2 simulation models to get the outcome. As you can see, this one is the automation simulation model. From the right-hand side is medicine racks, the dispensing machine, and the conveyor belt. The medicines will drop and go through the conveyor belt to the pending area, and finally put into bump box and for patients to collect. Actually, this whole process is all the automation process without any human handling. And when we create the simulation model, we actually make 2 assumptions. The first one is because we have no idea how actually the patients will, what distribution they will come in. So we did the time study by recording the time interval of patients and apply the distribution model to both models to compare the outcome. And the second assumption is for the manual model we create, we actually work out the process time based on the MODEPS, which is modular arrangement of predetermined time standard. We assume that all the staffs are able to finish the steps within the standard time. Yeah. And we can come to the simulation outcome. The robotic and manual one, the index performance index we take is the average processing time. Means the every patient need to go through how many time, how long to finish the process. For the automation system, it only takes 83 seconds, but for the manual one, it will take 98 seconds. And for the average waiting time means when they arrive at the pharmacy, the robotic system, they only have to wait about 3 minutes, but for the manual one, it will need to wait about half an hour. And the average length of queue means when they arrive at the pharmacy, there may only 2% in front of, for the robotic system, but there will be about 8% in front of you if using the manual process. And actually, the processing time is much longer. And lastly is the numbers of patients can be served within 1 hour. When we're using the robotic system, it can serve 42 patients within 1 hour, but for the manual one, it can only serve 18. As you can see, there will be a large improvement if we implement the robotic system. So next, Lisa will introduce more about the possible improvement in the future.
Because what we did is related to the hospital pharmacy, which is related to the healthcare, personal healthcare companion. Okay, so we think in the future, something so-called a personal healthcare companion will come out. What does the companion will do for you? Basically, there will be simply 3 steps. The firstly will monitor body index and give a presumptive diagnosis. And they will generate a health report and send the prescription list to the automation pharmacy. And lastly, the hospital will deliver the medicine to the patient's house. During the whole process, the patient doesn't need to go to the hospital, make appointment with the doctor, or wait the long queue for collect the medicine. He can get the medicine at home and stay at home and have a good relax. Yeah. Lastly, my teammate Jin Yi will draw a conclusion.
We all know the implementation of robotic system will contribute to higher and more stable accuracy, productivity, and lower cost. Yeah. Nowadays, robots are mainly used to lift heavy objectives, handle chemicals, perform assembly works. As comparing to manual work, robots are able to do the same works with precision, rather than making errors associated with fatigues. That's the reason why the robots are ideally used to perform our topic, which is the outbound of the pharmaceuticals.
Thank you, Ingenious team. Judges, because we're actually running out of time, so please make some quick comments.
Okay, quick comment. I applaud the forward-thinking nature of the project. You know, it's a bit sci-fi, I think, because when you think about medication and you think about the person who's on the end, who's receiving the medication, there's probably a lot more anxiety than just taking a bag of pills, right, and popping that. So that's something else to consider. But I think overall, generally good flow. I mean, a bit of start and stop, right, in terms of the flow, but generally okay. But I'll say just think of the human aspects and think of the customer, right, that's in this project.
Yep, overall, pretty good structured flow, pretty nice slides, good use of both slides and also videos. And I think it's a very smart use of the videos when you narrate on the video with some of the components. I guess all three of you, English is not your native language. So that is a very intelligent approach so that you won't go wrong explaining what you want to do. Pharmaceutical, yes, I think it's a high value industry. So it's a nice target industry. I have a problem when you start switching between trying to sell me. Initially, when it was a brick bulk, I was looking forward to a brick bulk solution. But it didn't go into a brick bulk solution. It went into a picking solution. Yeah, it's a picking technology. And then it's a very postal system, you know, where we use in SingPost. You know, it's a very postal system. Pretty good adaptive approach, good time studies, good assumptions. I like that approach in terms of, you know, it's structured, you get to follow it. But yeah, one thing it was not addressed for discussion is that what if I don't understand and I cannot follow process? A lot of old folks don't follow process. You know, I have a problem following that process. Correct? 很多人不会跟着流程走. Yeah, then you will have a problem. You don't follow process, you know, it's like, where am I going to go? They will still go and ask people, what am I supposed to do? What happens if you don't use smartphones? That's another problem. My dad don't use smartphone. He used the Nokia buttons, you know. So I got a problem as well. So you need to address some of those gaps and how you're going to argue some of those gaps. But otherwise, maybe, yeah, 20 years later, I think that would be great. Thank you. Very good.
Thank you, Ingenious team. Now let's move on to our last